Welcome to this lecture. In the last lecture, we had started discussing the testing issues, looked at some very basic concepts. Today, let us build on the aspects that we had discussed last time. If you remember, in the last lecture, we had discussed about the types of testing: unit, integration, system. These are the three levels of testing: unit, integration and system. And then we have the regression testing, which is a different dimension of testing. We had looked at some very basic concepts of unit testing and integration testing. In the system testing, we just started to discuss last time. Now, let us proceed further. We can consider system testing to be two types, either a functionality test or performance test. In other words, if we have to do a system testing for some software, we have to write two types of test cases. One is the functionality test cases and the other is the performance test cases. We will see what the functionality tests need to test, which aspects, and which aspects will be tested by the performance test. We can also consider the system testing to be of three types based on who performs testing. There are three different types of system testing. The alpha testing is done by the developing organization, the testers in the developing organization. This is a type of system testing which is first performed, and after the system passes the alpha testing, beta testing is performed. Beta testing is performed by a set of friendly customers or users. And after all the issues that arise during beta testing are addressed, the acceptance testing is performed, and acceptance testing is performed by the customer. Once the system is delivered to the customer, perform the acceptance testing and they accept the software if it passes the acceptance testing, otherwise they return it, they do not accept it. Now, as we proceed, we will look at the functionality test. The functionality test is basically all the functions that are documented in the SRS document. It is tested whether all those functions are working fine. The second category of tests that have to be developed, the test cases, and to be executed are the performance tests. The performance tests determine whether a system or subsystem satisfies the non-functional requirements. So, both the functionality and the performance test in system testing are designed based on the SRS document. The functionality tests are designed based on the functional requirements, and the performance tests are designed based on the non-functional requirements. There are several types of functional tests. The response times, whether all the response times are met, throughput, usability, stress, recovery, configuration, etc. There are many types of performance tests, and later in this lecture series we will see what are the aspects that are tested in these different types of performance tests: throughput, usability, stress, recovery, configuration, etc. just to have some more basic ideas on testing, once the software is delivered to the customer performs what is known as the user acceptance testing or acceptance testing. They just check whether the system fulfills all their requirements, and based on their test they either accept or reject the software. Now, based on our discussion so far, we can see that a software is tested by different types of personnel. One is the developing organization. The programmers who wrote the software, they perform the unit testing, and they may also test the other programmers' code if necessary. So, the programmers themselves are one type of tester. The users, they perform the usability and the acceptance testing, and some of the friendly users, they may do the beta testing, and then often the organizations have a separate test team, and they do all testing, that is integration, alpha testing and so on. So, they do most of the testing excepting the unit, beta and the acceptance testing, and also they develop the test strategy, that what kind of tests need to be performed, and they also develop the test plan when, in what sequence the tests need to be applied. If we look at the broader picture, in the development life cycle, we have just shown a iterative waterfall model. In the initial stages of the waterfall model, you can see that the review is done after the end of every stage. The SRS document is reviewed during the requirement analysis and specification. During the design document is reviewed, the code is reviewed, and there may be necessary to simulate these, and these are all done by the developers. So, in the initial stages, the testing is done by developers, but during the testing stage, where the integration and system testing is carried out, the testing is done by the tester. Let us look at another very important fundamental concept in testing, and this concept goes by the name pesticide effect. This concept is given the name pesticide effect because of its analogy to the use of pesticide in a crop field. Let us assume that we have a cotton crop, and then the farmer found that it is infested with pests. So, what does the farmer do? So, these are the pests who have infested the crop, and the farmer would apply some pesticide, and then most of the pests get killed, but then few of them are survive. Now, in the next season, when the farmer plants the crop, again those which had survived, they multiply, and also new types of pests come. Again the farmer applies pesticide, but then if the farmer applies the same pesticide, let us say DDT, those which have survived DDT, again applying DDT will do nothing to them, because they are resistant to DDT. So, the farmer needs to apply a new type of pesticide. let us say malathion, and then many of the pests get killed. But then those which survive, again they appear in the next crop, multiply and appear, and new types of pests appear. But again applying malathion will do nothing to these pests, because they had survived malathion and malathion does not kill them. So, the farmer needs to apply some other pesticide. In testing, it is the same thing. There is a very strong analogy with the pesticide effect in crops. We can state by saying that errors that escape a fault detection technique cannot be detected by further applications of that technique. What it means is that we have many types of testing technique, dozens of testing technique. We will see some of those, maybe we will look at a dozen, but then there are several dozens of testing techniques. Each time we apply a testing technique, some of the faults are detected, but then some of the faults escape. And if we again and again apply the same testing technique, we will be not detecting those which had already escaped, because this testing technique does not detect those kind of faults. We need to apply a new type of testing technique or a different type of testing technique, and we catch some of the faults, and again apply another testing technique. So, the bugs which escape a testing technique, further applications of that same testing technique will yield very little result, and that is the reason why in a software development organization several types of testing techniques are used one after other, and this is called as the pesticide effect. Capers-Jones, who is a well known researcher in the area of testing, he had written a article in the IEEE Computer in 1996, and he had proposed a rule of thumb in that article. It states each of software review, inspection and test step will find 30% of the bugs present. So, what he says is that each of these can be considered as a bug filter. In review, we get some bugs exposed. During inspection, we get some more bugs exposed, and then there are various types of testing, and in each of those we get only 30% of the bugs present. So, initially if the code had 1000 bugs, review will catch 300 of them. Out of the remaining 700, 30% is 210. 210 will be obtained by inspection, and then we have 490. And out of that 490, apply unit testing, we will get 30% of that, which is about 182 or something, and so on. So, that is the one he had experimentally observed, that each of the software inspection and testing technique can be considered as a bug filter, and these bug filters can find 30% of the bugs present. Now, let us do a small arithmetic, small problem based on this pesticide effect. Assume that we had 1000 bugs and we deployed 4 fault detection techniques, and each technique is highly successful. Unlike what Capers-Jones had written, our techniques could detect 70% of the bugs existing at that time. So, after the application of 4 detection techniques, how many bugs should remain at the end? So, you can do it initially. After the first technique, 300 will survive, 70% will get detected out of 1000. So, that is 700 detected and 300 existing, and then again 30% of that will survive, and so on. We can do it quickly by noting that it is equal to 1000 into 0.3 to the power 4, because each time only 0.3 survive. So, the total surviving bugs out of the application of these 4 techniques is 81 bugs in this program, and this is a big number of bugs, 81 bugs. When the users encounter these bugs in failure, they would be extremely unhappy and they will call it as a poor quality software, and therefore, we need to have many more bug filters such that the bugs reduce to a very small level. Now, let us have a small quiz. Given that this is the iterative waterfall model, when exactly are the verification tasks undertaken in this model? In which stages are the verification work undertaken? Okay, the verification in the form of review, inspection, simulation, etc., are done during requirements analysis, design, and coding. That is the answer. When is testing undertaken in waterfall model? Okay, to answer this, we can say that the unit testing is done during the coding stage, and the integration and system testing is done during the testing stage. When is the validation undertaken in waterfall model? Validation, if we remember from our last lecture discussions, validation is basically system testing, and system testing is undertaken during the testing stage. Now, let us look at some more basic concepts in testing. Let us assume that you have tested one software very thoroughly, or let us say a developing organization developed a large software and then tested it very thoroughly using the available techniques. How many errors will survive after all the testing activities are over and success report for all the tests have been obtained? Several studies have been undertaken on this issue, Jones, Schroeder, etc., but then they conclude that a typical testing process removes 80%, 85% of the errors, and 15% continue to stay, and those are called as the latent errors. But then why can't we remove more errors? Can't the testing techniques remove 99.9 or 100% of the errors? Why they remove only 85% of the error? The answer to this question is that all the testing techniques that we will discuss are basically heuristic technique, and these do not guarantee that they will detect all errors. So, all the testing techniques are heuristics. They help to reduce the bugs, but provide no guarantee of complete removal of bugs. This is a important observation, that all testing techniques which we discuss are heuristics, and they help to only reduce bugs, do not provide any guarantee concerning complete bug removal. What do we mean by test cases? A test case we execute to establish whether some functionality is working correctly. When we execute a test case, some of the program elements are executed, and therefore, we can consider the effectiveness of a test case based on how much coverage is achieved by that test case. So, the coverage measurement of test cases is a important metric for test cases, but then we also have another one. Many test cases we design them for detecting specific types of faults, for example, arithmetic faults and so on. So, we call them as fault based test cases. So, the test cases are two types. One, we measure the effectiveness of the test cases by the coverage achieved, and the other is how many faults they are targeting. Now, let us look at a finer distinction between a test data and test case. Test data, as the name says, it is just the inputs, test inputs that are given to the system. These are the data, basic data to execute. Whereas the test cases not only contain the input data to the system, not only describe the input data to be given to the system, they also describe at which state of the software this data needs to be input, and also the predicted output that should be obtained from the input. So, test data is just a component of the test cases, and in addition the test cases contain the state at which the input is to be given, and also what is the predicted output corresponding to the inputs. Based on that, we can say that a test case has three components, I, S and O. I is the input data or test data to the system. S is the state of the system at which the data will be input, and O is the output that should be expected. Just to give an example of the state at which the data to be input, let us consider a functionality in a library system, like let us say renew book. For a renew book test case to be executed, we must have the same book already issued out to a member. The book should have been created, that should exist in the library, and then it must have been issued to a member, and only then that member can renew it. So, we call that as the state of the system, that is unless the book has been created and the book has been issued out, this test case of renew book will not work. Every software is tested using a set of test cases which are carefully designed, and all these test cases which have been designed to test the software is called as a test suite. Now, let us see another basic concept which is about negative test cases. We have been so far discussing about positive test cases which detect bugs in the code, that is, the software does not do something it should have been doing. But negative test cases, these provide unexpected or invalid inputs and then see how the system behaves. The system should behave gracefully, it should not crash. For example, if it wants the number of books to be entered, number of books to be issued is to be entered, and the librarian entered, let us say, instead of a number just entered something like a digit, sorry, an alphabet like A or something by mistake, and then the system should not crash. So, the aim of the negative test case is to give some input which is not really the correct input to be given as per the SRS document. These are wrong inputs, but just to check that the system behaves acceptably and does not crash. For example, in a numeric field, a user types a alphabet, and then it is to be observed that the system does not crash and displays a polite message that data type entered is incorrect, please enter a number. But as the test execution is done, the test cases have been designed. How is the test execution done? All the test cases have been designed, and now the test execution needs to be done. Tests have to be executed. So, the program has to be put in the required state, the input has to be given, and the output has to be observed. We are almost at the end of this lecture, and with this set of basic concepts on testing, we will just stop here, and we will continue in the next lecture.